Hello class. These are the notes for solving linear equations and inequalities by graphing. So I know a lot of you don't own your own calculator at home, so I want to give you some options. There's an app that you can download on your phone called the Andie Graph. There's the name of it right here, Andie Graph. And here's what the app looks like. So, it's an option. You can download this if you would like to have a graphing calculator at home. Let me show you what it looks like here. See, looks just like our calculator that we use in class. So there is one option for you, okay? So let's take a look at this worksheet. Okay, I'm going to change the problems. For some reason, when I went to print this out, it was the wrong worksheet. So we are going to be solving, here's the actual title, solving absolute value equations and inequalities by graphing. Okay, so we're going to start off with, I'm going to get rid of this, and our first problem is going to be the absolute value of x equals 3. Okay, so now if you don't have a calculator, it's okay. Follow along and you'll be able to practice this in class. Okay, the calculator instructions are kind of right up here and they're written for you. So in Y1 on your calculator, so you're going to press Y equals, you're going to put in the absolute value of x. Okay, so to get to absolute value, you're going to go to Math, NUM for number, and it's the very first one. ABS stands for absolute value. So absolute value. Okay, so in Y1, we're going to put in absolute value of x. Okay, in Y2, we're going to put in, on the right side of the equal sign, we're going to put in a 3. Okay, so we put a 3 in for Y2. Okay, then we follow these steps. We go to zoom 6. So zoom 6 for a standard window. Okay, there's your first Y1 and there's Y2. Okay, and then the solution is where they touch. So these 2 points here, the x value of these 2 points. So following the rule, press second, calculate, and then 5 for intersection. Okay, so notice my cursor is right here. Okay, I want to find this intersection point, so I'm going to arrow to the left till my cursor is kind of close to it. It doesn't have to be right on it, but kind of close to it. And you're going to press enter, second curve, enter, guess, enter. Okay, so our first intersection is going to be at -3. You're going to look at this right here, -3. So if I was sketching this, it's going to look like that. So we got that intersection point. Let me move up here a little bit. Okay, now we're going to find this intersection point on this side. So again, second, 5, second graph, calculate, 5 for intersect. Okay, and then we're going to arrow to the right, move that cursor over to the other intersection point. Okay, enter, 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 and this point is at 3, 3. Okay, so we're solving for x. So the x value is going to be -3. And +3. So that is your solution set. Okay, we did an example like this in class. Okay, let's take a look at number 2. I'm not going to use this one either. So we're going to use the absolute value of 1/2 x minus 3 equals 5. Okay, so you should know how to solve this algebraically based on the last video we did, but we're going to do this one using our graphing calculator. So again, we're going to put the left side in y1 and the right side in y2. Okay, there's your left side. There's your right side in for y2. Okay, graphing it. Okay, so notice you can't see both intersection points. So we need to go further to the right so that we can see this intersection point. So we're going to go to our window and we want to go further to the right. So that would be x maximum would be to the right. So I'm going to go ahead and go to 25 and see if I can see it now. Okay, good. Okay, we're going to do second calc, intersection, the one on the left. Close enough. Enter, enter, enter. So one of our solutions is going to be -4. So let's go ahead and sketch this. Let's see. So this was -4, 5. So we know one of our solutions is at -4. Okay. Finding the other one. Second calc, intersection, and then arrow over to the right. Okay, enter, 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 and 16. 16 is the other solution. Okay, so that is solving linear equations by graphing, absolute value equations. Okay, now let's take a look at some inequalities. By the way, if they do not intersect, okay, there's no solution. There's no solution because there's no intersection points. So let's take a look at another problem. This time, let's look at the absolute value of x is greater than 3. Absolute value of x is greater than 3. So we start out the same way. Let's see if I can fix this a little bit. So, and then 3 goes in for y2, just like we split it down the middle. The left side goes first, right side goes second. Okay, graphing it. Let me just take a moment here to give you another resource. If you go onto the internet, if you have that available, and you type in Desmos Calculator, okay, Desmos Calculator, it'll bring up a calculator on that you can use. It's not like the one we use at school, but you can graph here. So you can just type in y equals, and let's see, absolute value. Let me see if I can, here we go, absolute values right here, down here, and we'll do absolute value of x, graphs it over there to the right, enter, y equals, and it's going to be 3. So that gives you a another graphing tool that you can use at home to graph things. Alright, so going back to our calculator, absolute value of x and 3. Okay, so visually speaking, we're looking for where is the absolute value of x greater than 3. Well, that's going to be above 3 on the right and above 3 on the left. So graphically speaking, that's what that would look like. So finding these intersection points, again, this is going to be at -3, 3, and +3, 3. So we're going to have x is, okay, less than -3 because we're going to the left. And we're going to the right here, shading to the right because it's above. So x is greater than 3. Shading to the right. Shading to the left. So going to the left, it's got to be a less than. Shading to the right, it's got to be a greater than. Okay? All right, let's take a look at another one. Number 5. Actually, yeah, this will be 1, 2, 3. Yep, number 4. Okay, let's plug that in. Okay, so I went ahead and graphed the absolute value function and the constant function here. Found my point of intersections. Okay, now it says that the absolute value function is greater than or equal to 5. Okay, so greater than is going to be here and here. Greater than is going to be above this line. Okay, it says right here greater than 5. So that would be above. Okay, so let's do this side first. So since we have an equal sign, x is going to be less than or equal to -2. Okay, we're looking at our x values for solutions. And then we're looking at the x value here. So x is greater than or equal to 8. Remember, less than because we're going to the left. Greater than because we're going to the right. Okay, let's take a look at a less than. So we have the absolute value of x minus 3 is less than or equal to 5. Okay, so we put this one in for y1, this one in for y2, and then we graphed it. Okay, then we use the instructions to find our points of intersection. Okay, and because it's less than, we're going to shade below 5. So here's 5, so we're going to shade below. So we're shading below, and we're shading below. Okay, so the solution is from this point to this point. So we start on the left, -2, okay? So x is going to be greater than or equal to -2, but it's going to be less than or equal to 8. So it's going from -2 on the left. All of these are solutions, all the way up to 8, from -2 to 8. Okay? And we'll go ahead and stop right there. I'll see you guys in class today. Hey, Wendy, how are you? I'm sorry. Allergies?